Welcome back to Visual Patterns. This is pattern number 106, and it is a really cool pattern because it involves squares, which can be interpreted in many different ways. So let's begin by filling in the table. We have the first three iterations, 1, 2, and 3. The first one, 2 purple squares. The second one, I see 2, 4, 5, 6, 7. The third one, I start to see, well, there's like a square of 3 by 3 plus 3 plus 2, so 9, 12, 14. Okay, now let's think about the fourth iteration. Well, to do that, let's look at the first ones. One way of interpreting this is to see that for every iteration, there's like a square built in that has length and width of the iteration number. So literally, the area of these sections is the iteration squared. So it's x squared. So here for the fourth iteration, there's going to be a 4 by 4 square. I can see that built in. And then what about this extra stuff? Well, here there's 1 square. Here there are 3 squares. Here there are 5 squares. And they're all related somehow still. But if I look carefully, I'm going to begin with the third one and work backwards. Here's a row of 3, and that's the iteration number. Here's a row of 2, that's the iteration number. Here's a row of 1, and that's the iteration number. Now, going down, then there's 2, then 1, then there's nothing there. So again, these numbers 2, 1, and 0 are related to 3, 2, and 1. They're always 1 less. So let's go back to our equation up here. We know there's an x squared involved, and then there's also plus x, that's the 3, 2, and 1. But then this section is always 1 less than the x value, so it's plus x minus 1. So just to reiterate, for the fourth iteration, then there's going to be a level here of 4 pieces, and then a section going down of 3. So we have 16 plus 4 plus 3. So 16 plus 4 plus 3 is 23. And then we can also start to see in here, there's a change of the first 2 iterations. You got 5 more squares, then 7 more squares, then 9 more squares. So that's a growing parabolic pattern. But then the second change is by 2 every time, which identifies it as a quadratic equation. So that's one way to look at it. Now let's look second way. This was our first equation. So remember, the y value, the number of squares, equals this x squared plus x minus 1. Now, a second way to see this equation is going to be to build, and a lot of students saw this too in my class, if you build a square out of the existing shapes, you begin to see the pattern right away that they are squares, but there's always like these 2 pieces missing out of each square. And in some ways, that's a more efficient way of looking at this pattern. So if I see that, I know that a square is length times width. So all of these can be length times width. Even this fourth iteration, it's going to be a length times width. But how do I determine the length and the width? Well, I can see for the first iteration, it's 2 by 2. Second iteration, 3 by 3. Third iteration, 4 by 4. And then the fifth iteration is 5 by 5. But then there's always a minus 1 and a minus 1. So let's see if that bears out with our previous information here. So 2 times 2 is 4 for the area, but minus 2, 4 minus 2, that's 2. 3 by 3 is 9, minus 2 is 7. 4 by 4 is 16, minus 2 is 14. 5 by 5 is 25, minus 2 is 23, so it works. So how do you write this equation? Well, again, these are the x values. So 2 is 1 more than 1, 3 is 1 more than 2, 4 is 1 more than 3, 5 is 1 more than 4. So it's definitely x plus 1, and that's the length and the width, so it's squared. So, whoops, x plus 1 squared is what's happening, but then after that, we're removing these two values, these two corners. So this equation and that equation represent the same diagrams, so they must both be accurate. Let's try it out by putting in 15. So let's start with here. So 15 plus 1 is 16. 16 squared minus 2. So 16 squared is 256 minus 2. That would give me 254. Remember, in here, we're looking for what is the value of any y in terms of x. So in here, I can put either of these expressions, and they would both be true. But again, we're checking. Let's go ahead and use 15 in this equation. We have 15 squared plus 15 plus 15 minus 1, which is 14. So 15 squared is 225 plus 15 plus 14 is 29. 225 plus 29 is 254, which is equivalent to what we got with the other equation. So therefore, they're both true. This all works out. Again, this is a great visual pattern to work with students who are looking at quadratics, because then when you graph this data, it's really helpful, because then they can learn about what plus 1 does to the parabola on the coordinate plane, and also what minus 2 does. So try that out. Let me know how it goes. Please like and follow for more. I have many more videos on how to demonstrate and show visual patterns. It's a great way to get those brains growing. Thanks. Have a great day.